Hello, welcome to our Topic 5 Challenge Electricity video. The members of our group are Gavin, Howarth, and Ryuki, Koda. Our problem is how to form a closed circuit to produce electricity. Some requirements are that there must be a switch in the flashlight. We must include calculations of electric potential energy, resistance, power, and current using multimeter and Ohm's law, which is I equals VR. We should try to wire the materials in series and then parallel without breaking the rest of the flashlight before finalizing our design. The bulbs have to be connected. We need to have circuit diagrams explaining how maximum brightness was achieved, and 2 bulbs must be lit. Some constraints include making the best use of our materials, the materials we should use and others that we shouldn't, putting all the materials together to make a circuit and to light the light bulb, and the order of materials will also be important to help the light bulb light up. Forming parallel circuits and calculations for these circuits, connecting the bulbs so that they can be as bright as possible, and the different calculations for electric potential energy, resistance, power, and current using the multimeter and Ohm's law. This is my series circuit of the flashlight. So the 2 light bulbs are connected to each other with the same cord. They all have the same current, and the total current is 0.05 and the total voltage is 1.57. So they're connected so that they share the voltage of this battery, so they split it. Each of the bulbs have 1.57 volts. Due to the fact that there's more resistance, there's less voltage and current. Here are my parallel circuits. I have 2 because the circuit builder wouldn't have the total amps, which is 0.27, so 0.13 plus 0.14 equals 0.27, so that's what it should be. So there are 2 light bulbs, one right here, one right here, and they both have the voltage of the battery. And this is because they go on separate paths, and so it overall creates more voltage and current than the series circuit. This is the design that my partner and I decided to do. So right here are the batteries, which each have 1.5 volts, which equals a total of 3 volts. And here's the switch, and then the wire, and the resistor, also known as the light bulb, and then wire, and there's 21.43 ohms in this resistor, and 23.08 ohms in this resistor. In a parallel circuit, there are multiple paths for the voltage to travel. The 2 light bulbs have their own branch to themselves. The voltage and the current is higher in this circuit than a series circuit, but there is less resistance. This is due to voltage and current's direct relationship and resistance inverse relationship with the voltage and current. The current in the parallel circuit was 0.14 amps for bulb 1 and 0.13 amps for bulb 2. The voltage was 3 volts for both of the bulbs. In a series circuit, there's only one path for the voltage to travel. The two light bulbs have to share the wire. The voltage and current is less in a series circuit than a parallel circuit, but there's more resistance. This is due to the fact that resistance is increasing, so the voltage and current would decrease because of their inverse relationship. The current in the series circuit was 0.07 amps for both of the bulbs. The voltage was 1.57 volts for both of the bulbs. The advantages of a parallel circuit is that it is brighter than a series circuit, and a flashlight in a parallel circuit could be used to find something in the dark. Also, in a parallel circuit, you can turn one of the light bulbs off while keeping the other one on. The advantages of a series circuit is that it lasts longer than a parallel circuit because it isn't as bright. Also, they use less energy than a parallel circuit.